Should we start? Rakotam will anyway take a couple of minutes.
Yeah, Sharmili, maybe you can share your screen.
Okay, I see Saurav there. Should I go anyway?
We can get started. Yes,
Yeah, I'll do.
you have the
I'll
slides
just.
anyway.
Okay, fine. Later I'll.
Okay. I see someone sharing actually.
Yeah,
Yeah,
so
I'm sharing actually.
Saurav's only. Okay.
Hope my screen is visible.
yeah, it
Yeah,
is.
sir.
You can go on presentation mode.
Okay.
Okay. Can we start? Okay. Hello, everyone. Happy Friday. Good evening. Hope you're all doing good. Uh, Today, we'll be talking about designing cost-effective ML systems. And this is just one of the talks as part of a series of talks we want to share from our experience as part of economies of data, economies of uh, doing data science at scale. So I am Raghutam. Uh, I'm part of the PayPal team. I lead NLP and computer vision teams. And with me, I have Sharmili and Saurav. And as part of the NLP and computer vision teams, the capabilities that we are building in-house are a plethora. To name a few, we are working on topics like intent detection, translation, summarization, semantic search, content moderation, smart replies, entity recognition, to name a few. There are a lot more. And on the computer vision side, mostly we are focusing on document intelligence, where we are building in-house OCR, document similarity, document understanding, classification, and so on. So over the past 2 to 3 years, we've been building and expanding our in-house ML capabilities, and we have a suite of uh, solutions that we have built that are facing internal and external customers. Uh, Saurabh, can you go to the next slide? I'm not sure if it is switching. We are still in the first slide. Yeah.
Yeah.
So we have a bunch of solutions that are facing internal and external customers, and this is at a really large scale. And we have gone through the journey of deploying these as POCs, pilots, scaling them at really large scale. Sharmili and Saurav are the experts here in MLOps and they've been doing all the good work in deploying them to production, maintaining and optimizing and reducing our infrastructure cost significantly. Uh, so this talk will be mostly giving you a primer on a framework we use to make a few decisions. Of course, Sharmili and Saurav will deep dive into that. But post this, we will also do subsequent talks on further optimizing costs and what are the areas. Uh, yep. So over to you, Sharmili and Saurav.
Yep. Thanks, Raghutam. Thanks for the good, wonderful intro. So I'll quickly start with the agenda for today. So I'll briefly introduce the topic, what we are going to discuss today in this first talk in the series, and I'll also introduce the an example use case which will be translation use case. I'll also share a bit of a journey which we went through for this use case, and I'll also introduce the evaluation framework which we use specifically for this use case to do the cost analysis. Post that, I'll hand over to Saurav, who will cover and walk us through the cost comparison analysis sheet and also share the insights and the key takeaways and learnings. With that, let's go to next slide, Saurav. Yeah, so what's the topic we are discussing today, right? For any new ML use case which comes to our team, right? So the first question which comes to the table is whether this ML use case is already being solved by other vendors, or is it available out of box in the market, right? So can we use the can we use the vendor solution, but or should we actually develop it in house to customize it better for our own solution, or our own PayPal data, right? So when we have to decide build versus buy, there are multiple factors which come in. So but if we can group the factors majorly, we can group it into three main categories, right? So one is features, other is performance, and the operating expense. So features are generally very much use case specific. For example, if you want to talk about translation use case, right, features will be like whether the solution, how many languages can it translate the given solution, right? Or does it bring it with it the language reduction capabilities? Does it support locate, etc.? Will be the features which we are talking about, which is very much use case specific, right? The other dimension to it is the performance. Inside performance, there are two areas, right? One is the solution performance itself. For example, in case of translation, it can be the quality of translation, right? Or the other set of performance is the infra performance, be it the latency or throughput requirements, right? And the third main area is the operating expense, which will be the main focus of our talk today, right? So today we will talk about how what are the factors we consider in factors of operating expense we consider when we decide between a vendor solution which is versus a homegrown solution, and also we'll a bit touch upon the one of the dimension in performance, which is the latency and throughput. With that, sorry, can you go to next slide, please? Yeah. So coming to the use case, let me introduce the translation use case. So we started this use case around H1 of 2022 last year. And when we started, so we know PayPal has been using translation by the time itself in a large scale fashion, right? So we know PayPal is spread around 200 countries, and we are serving 25 plus languages, right? So we had hundreds of teams inside PayPal who were using translation, and we were approximately translating up around 8 billion plus characters every month, right? So then we got curious about what these teams are using translation for, right? So then we did a bit of drill down, and few of the applications is what I have presented in this slide. For example, say we are having a conversation with a customer, so whether to identify whether the customer has come in with a complaint, and categorize the complaint itself into buckets, right? That's a complaints identification use case. And similarly, when there is a conversation with the customer, can we identify the intent of the conversation with the customer? Can we bring out some entities from the customer's conversation? Or for that matter, if the conversation is very long, can we summarize the conversation, right? These are the few of the applications which were predominantly using translation. Why? Because um, if the conversation is in English, then it is easier for these applications to do what is intended for, right? But most of the time, the conversation with customers are there in their own native languages, which is non-English language, right? In that case, these applications find it difficult because these applications are generally more optimized for working in English language. So they use a mid application, which is a translation service, where they translate the non-English language to English, which is a de facto language, and then do their functionality, right? So we saw this pattern occurring across multiple downstream applications. So this brought us to the requirement of there is a need for a centralized translation service, right? So whatever conversation or content non-English content we have in paper, we want to have a centralized translation service which can translate it into English, and then that can be consumed by a number of downstream applications, right? So now, after narrowing down that the requirement and necessity for centralized translation service, the next obvious question is: should we go for a vendor solution which is available in the market, or should we do it ourselves? Should we build it in house, right? Next slide, please. Saurabh. So when we came here, so we did also analyze few of the solutions which were available from different, mainly the big chains in the market, right? Be it Microsoft, IBM Watson, Amazon, Google Translates, and also Unbearable. So there were multiple vendors who already provided, who were already having good solutions for translation, right? But also there was a question, we might want to do a in-house solution because it can be more customized for PayPal data and PayPal conversations. So now we wanted a framework where we can take this decision, right? That's where we started a evaluation framework. So next slide, please. So this is the framework which we use to compare between two solutions. The two solutions can be vendor A versus vendor B, or it can be a vendor versus an in-house solution, right? So there are three main verticals which we used for comparison. One is the solution features, other is the performance, and third is the cost, right? Solution features, as I touched a bit earlier, these features, a few of these features are very much aligned with the use case itself. For example, for translation, we did check on the detection capabilities, local support, and number of languages the solution is able to translate for, right? Besides this, there are also certain features which is not really use case specific but bit agnostic. For example, whether the solution has inbuilt security and privacy complaints, whether it supports us supports customized training on PayPal data, right? And or whether it supports all the three types of serving, streaming, real time, and batch, right? And besides this, the next vertical, which was very important to us, is the performance. So we wanted to compare the translation quality among between the vendors, or between the vendor and the in-house solution. Besides that, there is also we also wanted to check the latency and throughput, whether our latency and throughput SLAs are met, right? And the third main vertical is the cost. So there are two major costs. One is the workforce cost, and other is the infrastructure cost, or in case of vendor, it's a API cost, right? And both costs are involved in three phases of any solution: the development phase, maintenance and tech sustenance phase, and R&D and retraining phase, right? So today in our talk, we will, as an example, we will compare our in-house solution versus a vendor solution, which is a GCP translation API. And in this, we will mainly cover the cost factors, both workforce cost and infrastructure cost in the development and maintenance phases mainly. And we will also cover the latency and throughput dimension of it as well, right? So before I hand over to Saurav, I just want to also mention that though we are going to specifically talk about translation use case today, as you can see, the framework itself is use case agnostic, and most of these factors are applicable across business use cases. So this framework can be easily extrapolated and can be used for any business use case, right? With that, I would like to hand over to Saurav to help us understand the cost analysis. Over to you, Saurav.
Yeah, thank you, Shamili. Yeah, hi everyone. So next I'll be talking about the cost that one has to incur when the solution is built in-house versus when the solution is simply subscribed or taken from major cloud providers such as Google Cloud Platform. So the idea would be that we would like to understand how much are we really paying when we build this text translation business use case in-house. And if we don't want to build, if we want to simply buy or rent or subscribe, then how much some money if we build a solution in-house, or in what scenarios the public clouds are better than building the solution in-house. So let's try to get a sense on all of these open questions, the factors with which we are able to, with which we can compare the cost between in-house versus public clouds. So that's what I'll be talking for the next few minutes. So yeah, I'll start the discussion. So for this comparison, we have built a cost analysis sheet. It's an Excel sheet. And here we have tried to capture all the, the important factors that we think can affect the translation cost or the cost to the business for this use case. So I'll start with the top. It says cloud versus in-house cost calculator for the translation business use case, but the same understanding can be extrapolated to any such similar business use case, such as text summarization, entity extraction, anything any AI/ML problem. So for this discussion, at the top, the factors that we see are the common factors which would be applicable for cloud versus in-house. So to start with, the daily data volume that we are considering is 1 million characters that we need to translate. Right? To build a solution in-house, we have to pay some amount of money, which will act as a compensation to the engineers. So we have considered it to be $30,000 on an average, especially for our geography, for India. Maybe for other geographies such as European countries or US-based locations, this salary-based compensation component would be much higher. So this is one factor that we have to consider when we have to build the solution in-house. And for our analysis, the average text length that we have considered is 250 characters. So actually, we built the solution in-house. We built a service, and we checked the performance of the service in-house on a text of length around 250 characters. So the numbers that we are talking about today is based on our tests on a text of length up to 250 characters. If the text length is more than that, maybe the throughput and latency numbers, the performance numbers would differ, and the cost would also differ as well. All right, so these are like the constants that I wanted to set for this discussion. And this data volume is 1 million characters per day, and we will vary it, we will change it, we'll increase it and see what is the cost trend looks like. If we vary the data volume, how is the cost trend looks like? Okay, so I have these three verticals here, the three sections here that I have highlighted. One, I'm calling it as GCP, basically the public cloud that we are using to for our use case, for our text translation use case. So GCP very well provides machine translation use case. We just need to send our data, and we can get the response in the translated language. So that I'm calling it as GCP, which is a managed service that we want to use from the cloud. The other one is the in-house solution that is going to run on GPUs. So I'm simply calling it as GPU. It is in the section which is in brown color. And the next section is the in-house solution that is going to run on CPUs, the section that is in green. So these three sections are the ones in which we are going to compare how much we actually pay when we build a solution with respect to these three sections, these three verticals. Okay, so when we had built our service, when we had started our journey, and when we actually built the service in-house, the latency that we observed was 0.8 seconds to translate a text of up to 250 characters. So, and this service was running on GPUs in-house. The service was running on GPUs, and the solution was in-house, developed in-house. So 0.8 seconds to translate 250 characters. It was 5 seconds to translate 250 characters on CPUs. I've mentioned the CPU and GPU configurations that we have used. It's mentioned, it's there in the sheet. But to mention that the GPU that we have used is NVIDIA's A140GB GPU, and the CPU that we had used was Intel Xeon processors clocking at 2.2 gigahertz. For GCP, we don't have the latency numbers because from the official page, there's no such mention of that. But from our experimentation, we observed that it's better than the numbers that we have seen in-house. And it should be, because at the scale these public clouds operate at, the latency and the throughput numbers would be better when we are using any major public cloud. So with that latency number, the throughput that we are getting is 1.1 million characters per hour. This simply means that we would be able to process 1.1 million characters in 1 hour with the GPU that we have. With the CPU infrastructure, we will be able to process 180,000 characters or 0.18 million characters in-house. So that's the throughput that we get. The throughput in the cloud, when we are subscribing to the cloud, would be better than the throughput that we have seen in our in-house solutions. We don't have a number for that, but we know we have observed that it's better generally. Again, the argument is that at the sheer scale which they operate, the throughput would be better than what we have seen in-house. So with these performance parameters, latency and throughput, and these are important to talk because they directly impact the cost that is going to be incurred. So the better these numbers are, the lesser would be the cost. So the higher the throughput or the lower the latency, the lesser you would pay actually to translate a text from one language to another. And that is why it is important to highlight these metrics. So finally, with latency and throughput numbers, to translate a daily data volume of 1 million characters, the time that it takes in the GPU infrastructure in-house is 0.9 hours, and it takes 5.6 hours to translate on CPU infrastructure that is in-house. Okay. So next comes to be the infrastructure cost that is associated. So the machines that we are using, we simply rent it out from GCP. So the rental cost that we are going to pay for a GPU-based compute instance or GPU instance is $3.5 per hour. This is a standard cost which is mentioned in the cloud platforms page. Of course, for an enterprise, these rates could be discounted, but to keep the discussion simpler, these rates are what is mentioned in the cloud platforms page. So it is $3.5 per hour. This is the cost of renting just the machine. And for a CPU that we are using, one has to pay $0.2 per hour almost. Yeah, so this is the infrastructure rental cost. If you are using a cloud-based solution, there won't be any infrastructure cost associated with it because it's a pay-per-usage model. You simply pay for what you use. So if you have to translate, you only pay for the translations and not for any infrastructure cost. Similarly, for subscribing to the service on cloud, there won't be any subscription cost in-house because we are only going to pay for the infrastructure cost. Once the infrastructure is set up, it's available, then we just have to use it. But on GCP, the subscription cost or the cost of this service is $20 per million characters. So for every million character that you have that you want to translate, you are going to pay $20 for that. So if you have 5 million characters to translate, you will be paying $100, 20 multiplied by 5. It's as simple as that. This is a flat rate. Maybe if you're a big enterprise, if you bring a lot of business to GCP, you can get some discounted rates, maybe 20-30% discounts you can expect. But at least this is the flat rate which is mentioned on their web page. All right, so this is we talked about the infrastructure cost and the service cost. Now let's try to understand how much is the translation cost that comes when we run our solution on in-house GPUs and CPUs versus when we run our solution or when we opt the solution from GCP. So if your use case is of type streaming or a real-time use case, on GCP, you'll be paying $20 to translate 1 million characters, right? For the solution running in-house, that is on GPUs, you will be paying $84. And the same solution, if you're running on CPUs, you will be paying approximately $28. This is based on the infrastructure rental cost that is here. And since it's a streaming service or an online service, so the compute instances have to be running all the time, 24/7. And that's how these costs are materialized. It's coming into the picture. If it's a batch use case, you'll still be paying $20 to Google, to GCP, because it doesn't matter there whether your use cases of type streaming or batch or real time, anything. It's just the amount of characters you want to translate. The billing happens on the amount of characters that you want to translate. So again, you'll be paying $20, but in-house, if the solution is in-house, since your compute instances will be running only for a specified number of hours, in this case, only for 1 hour to translate 1 million characters. So you'll be paying only that much for the amount of time your compute instances are up and running. So the GPU compute instances, if the solution is running on GPUs, you are going to pay $3 and $1 when it's running on CPU. So that's the daily translation cost that that one has to bear. And so from this daily translation cost, the monthly bill amount that we get for a streaming use case, which is running 24/7, it's $600, just extrapolated to a month. So 30 multiplied by 20. So it's $600 for streaming use case on GCP. It's going to be $2,500 for the solution that is running in-house, that is developed in-house, running on GCP machines. It is going to be $2,500 and approximately $850 when the same solution developed in-house and running on CPU infrastructure, it would be $850. For a batch use case, GCP turns out to be expensive, and the in-house solutions, solutions on GPUs and CPUs, they are much cheaper compared to GCP. Okay, so far the story is that if your solution is of type streaming or real time, right, then it's better to go for a cloud-based approach. You simply subscribe to the cloud-based solution, and you are better off. I mean, that's how the story looks like. And if your use case is of type batch kind of, where you know when that you know how much data you have to process and when you have to process that much data, so it's better to build a solution in-house, because for a batch use case, what we see is that the monthly bill is much lesser than the bill that one is going to incur on GCP. But there's one thing that we certainly need to consider is the cost of building the solution, right? Because when it is in-house, there would be development cost, there would be maintenance cost of the solution that we are going to build, and we should definitely take that into consideration, because then only we'll get a clear picture whether one should opt for a solution from public clouds like GCP, or whether one should build the solution in-house. So now let's talk about the development and maintenance costs that are associated with building the solution in-house. So in the case of in-house solution running on GPUs and CPUs, we have assumed that it requires a team of size four engineers to work for 3 months to build the solution, and based on that, the development cost comes to be $30,000. Similarly, we have assumed that it takes 2 engineers and 6 months to regularly maintain the service, maintenance in terms of fixes, feature enhancements, or any such similar activities. So that cost again comes to be $30,000. So if you see, when the solution is built in-house, you are paying almost $60,000. The company, the organization has to spend $60,000 just to build the solution in-house, just to make the solution ready, and in a stable state. The organization has to pay $60,000. Similarly, when you are opting for public clouds, so there the development efforts would be minimum, because it's just a matter of integration, just a matter of calling the APIs which GCP is going to provide. So there would be minimum development time, and there would be minimum maintenance time. And that is why the cost of development or the integration with the cloud platforms would be much lesser than the in-house development cost. Again, this is based on our understanding and assumption, but if we change the numbers, the cost will be changed accordingly. Maybe for some business use case, we would require a larger team size and a more development time. So that is understandable. And based on that, the cost of development would also change. Yeah, so far, what we know is that for a streaming-based use case, we are paying lesser. We are paying lesser to GCP. Plus, there's lower development cost, especially for a streaming-based use case. That's how the story so far is. For a streaming-based use case, we are going to pay more when the service is running in-house. Plus, there's a higher development cost that is associated, right? So now the obvious question is that why should one go with building the solution in-house? Why not simply choose the public clouds like GCP to use the solution? Like, why can't we simply go with GCP in the very first place? So that is true, and also not so true, because it all really depends on the scenarios that we have, and I'll discuss one by one the scenarios. So one of the most important factors that is coming into play here is the data volume. Right? So all these costs that we have seen so far is based on is for a data volume of 1 million characters per day. So the higher this data volume would be, the more the costs would be. That is also understandable. So for example, if I change this volume to 2 million characters, now the cost that we are going to pay to GCP is double, is $1,200. On GPU, it is still the same cost. Also, the assumption and the reason is that this data volume is uniformly distributed throughout the day. So since it's a uniform distribution, it is well under the throughput limits of 1.1 million character translations per hour, and that is why the GPU instances that is running in-house it can still cater to the increased data volume, and same for the CPU instances. So and this also means that our GPUs or our compute instances are now better utilized. Previously, for a streaming use case, they were underutilized, but now as the data volume increases, we are utilizing our GPU instances better, and we are not paying extra. But on the cloud, for every million characters, the more the volume increases, the more will be the cost. So now you can get a sense that more the data volume, more will be the cost, and the difference here would keep minimizing. This difference here would keep minimizing. So if I further increase the data volume, so now from $1,200 it increases to $1,800. Our in-house cost on GPU is still the same, and the difference is further minimized. It's low. So next, let's try to understand this behavior, that at what data volume we reached a break-even point, which means the point at which we are going to pay the same amount to GCP, and we are going to incur the same bill when this is run. Okay, so let's come to the cost trends and the insights that we can take from them. So I've set the data volume to 1 million characters from where we started. Actually, we saw earlier that it is $600 when we are subscribed to GCP. It is $2,500 approx when the service is running in-house, but on GPUs, and it is $850 when the service is running in-house on CPUs. If I increase the data volume, and as you can see from the charts, our in-house cost is much higher compared to the cloud cost. So at this point in time, it feels that we should stick with cloud. Also because on cloud, the development cost is much lower. In fact, it won't be there. It would be very minimum. Now, as I increase the data volume, if I increase from 1 to 2, right, so now the gap or the difference would be lower. It would be lesser and lesser now. Now, if I further increase to from 2 million to now 4 million characters per day. So yeah, now what we see is that our GCP cost and our in-house GPU costs are mostly similar, right? So it gives us a feel that 4 million characters is the break-even point, at least for this use case, for the set of parameters that we have considered. It seems that when your daily data volume is around 4 million characters, then from the cost point of view, you are going to pay the same amount, be it in-house or be it in GCP. But if the data volume is on the higher side, if from 4 million, if I increase it to 10 million, now the cost on that you are going to spend on cloud is higher compared to the cost that you are going to incur in-house. So now this presents a case that even the in-house solution can also be considered, especially when the data volume is on the higher side. And this I'm talking only in terms of cost. There could be other factors of deciding whether to go with cloud or in-house, but especially in terms of cost, when the data volume is on the higher side, it gives us a strong case to even consider an in-house solution. So these numbers are for a streaming use case. Even for a batch use case, we see the similar trend. If the volume is on the higher side, you are going to save even more when the solution is running in-house. In fact, for a batch use case from the very beginning, it is always profitable that you build the solution in-house because your compute instances will be running only for a limited amount of time. But the difference would be more pronounced if you increase your daily data volume. So if your data volume is more, the savings would be even more pronounced. So for 10 million characters, you're going to pay $6,000 as your cloud processing cost, but your in-house cost is just close to $1,000. So even for a batch use case. So now the story changes that when your data volume is on the higher side, even your when the data volume is on your higher side, then it is also it would be good to consider building the solution in-house, because now you are actually seeing that you are saving on cost. So the more the data volume, the larger would be the savings. And we would also like to know that actually at what point that break even comes, right? So for that, let's refer to this chart. So for a streaming use case, as we saw earlier also, so at a point of around 4 million daily data volume, we see that the cost that we have to pay to GCP is same as the cost that we are going to incur when the solution is built in-house. So the blue line, which is GCP, it is linearly increasing, because for every million characters you are going to pay $20, but when the solution is running in-house, till the time the traffic is well under the throughput limits, you're going to pay the same infra rental cost, and that is why it is flat at $2,500. And when the and for CPUs also, in fact, it is flat at around $900, $800. Yeah. So again, to summarize, when the data volume is on the higher side, it's okay to consider building the solution in-house. But still, there is one factor that we haven't incorporated yet. It's a development cost. We saw initially that it took almost $60,000 for us to build the solution in-house. So I'll go to the top and show you again. It's $60,000 we are spending when we are building the solution in-house. So let's try to understand at what point in time we can actually recover this $60,000 of in-house development and maintenance cost. So and this chart will give us this answer. So at around 4 million data volume, the cost on GCP and in-house both are same. But now when the data volume is increasing, and let's say if your data volume is now 10 million characters, so you'll pay $6,000 to GCP, but in-house you'll be paying only $2,500. So there's a saving of $3,500, and this is just for 1 month. In 1 month, you are saving $3,500. In 10 months, you'll be saving $35,000, and in just under 18 months, 1.5 years, that is, in just 1.5 years, you'll be actually saving your $60,000 of development cost. The amount that you actually paid to the engineers, to the team, to build and maintain the solution. So, and this is just for a data volume at around 10 million characters per day. If the data volume is even higher, maybe, and actually, this difference would be, this savings would be more realized, it would be more pronounced. And this is what is evident in this chart, which is just the extension of the previous one. So now when the daily data volume is even on the much higher side, so from 10 million characters to even, in fact, 100 million characters, you are paying $60,000 to GCP, but only paying $12,000 to run the solution in-house. And in just a month, you are saving $48,000 in the translation cost, in the data processing cost. And in just over 2-3 months, you'll be able to save your entire translation cost, your entire cost of doing this business. So the point here is that the higher the data volume you have, the larger the benefits would be when you are running the solution in-house, when you're building the solution in-house. From this chart, that is what this chart also tells us, that for for bigger enterprises who have a higher volume to process, they are going to be benefited more when they build the solution in-house versus when they are choosing the public clouds. At the same time, if your data processing requirements, if your translation requirements are pretty low, this is somewhere around 2 million characters per day, 1 million character per day, then it's okay not to consider building the solution in-house, because you are paying lesser overall. You're paying lesser, and especially I'm talking about a streaming use case for now. So it's okay to consider a cloud-based solution, especially when your data volume is on a lower side. And also you're saving on the development cost, because there's hardly any development cost when you're considering cloud, considering cloud. But as your data volume grows, you should also think of switching to or building a solution in-house, because for a larger volume, you'll be saving more cost. And in the longer run, it would definitely be profitable for the business, for the organization. The point is that this break-even point maybe can shift. Right now, for our model, it is coming at 4 million characters per day. If you include more and more such factors which impacts the cost, for example, we haven't incorporated high availability or scalability of the GPU instances, all of that. And to keep this discussion simple, we have only considered only one GPU server that is running in-house. But let's say if you increase it from 1 to 2, this cost will be double now, right? But the overall point is that the break-even point will shift. Maybe now it comes to, at a level of 10 million. But overall, in the longer run, you are going to be benefited if your data volume is on the higher side. So this is what I wanted to highlight. Yeah. So the analysis is mostly done. I'll just go through the assumptions that we have taken for this analysis. Like the first assumption that we have taken is that the daily data volume is uniformly distributed over the day, which means if it's 1 million characters, it is uniformly distributed throughout the day. If a burst of traffic is coming, then of course you will need more such compute instances running in-house if you're building the solution in-house. The scaling, high availability, plus many such principles are not included in the analysis. If you include such factors, the cost would the in-house solution cost would differ. But here's the thing: since the difference, the margin is so much, like on cloud, you're paying more and more as your data volume is on the higher side. You're paying $60,000 in the cloud, but in-house you're paying only $12,000. So even if you increase compute instances, the point is that since you have so much margin, these factors would be compensated in this margin, and you'll end up profiting from building a solution and running it in-house. That's the overall point that we want to make. The throughput and latency numbers what we have shown here is for the text length and for the model that we have chosen. For a different model, for different text length, the performance numbers would differ. And so these cost numbers would also differ. And these are the GPU specifications and the CPU specifications that we used for our analysis. I've mentioned the links in the references, the links from where this costs can be, from where I have taken these costs. Okay. Yeah, so that is about the cost trends and the insights. Next, I'll go to one last slide, which talks about the various factors with which we can decide whether to go with in-house or a cloud. The factors that can affect this choice. Right now, we only saw cost as the main factor, but apart from cost, there would be many such factors which can affect your choice. So the factors such as latency, quality, time to market, volume. So let's go through these factors one by one. Some of these factors are qualitative factors. Some of these factors are quantitative factors. But the thing is that there are multiple such factors which can affect one's choice of whether to go with cloud versus whether to stick with in-house solution. So if latency is your factor, if you want the solution to be very performant and it should work in real time with minimum response time or latency, then it's better to go with cloud because they can offer you that scale, that real time guarantees. This also we have observed. If quality is your concern, if you want your translations to be of highest quality, then again cloud-based solutions are preferred because of the maturity of the product they have, the R&D spendings that they do, and the cutting-edge technologies they work with. But yeah, so this is preferred again, like with a lot of in-house development and efforts and time, you can match the quality. But in general, you'll get a higher quality when you're taking the cloud-based solution. So in our testing, we actually saw that the translations coming from our in-house model was 3 to 5%. I mean, 3 to 5%. The GCP-based translations were better. The GCP-based translations were better by a margin of 3 to 5% compared to in-house translations. And this 3 to 5% is a metric called Blue Score. That is the appropriate metric to compare translations quality. And the cloud-based solutions were 3 to 5% better than our in-house build solution. Again, the work is in progress to better off this translation quality, to improve this translation quality further. But so far, this we have observed. So if quality is your prime metric, then it's better to go with the cloud-based solution. If some problem statement is it consists of a higher development complexity, maybe there's some AI/ML use case which would require a lot of time, a lot of development effort to build the solution in-house, then and you would want to reduce your development complexity, then it's better to go with the cloud-based offerings. If time to market is your primary factor, you want the solution to be available immediately, and you would want to reduce your time to market, then it's better to go with the cloud-based offerings. But when data volume is your concern, when you would want to process a high data volume in less amount of cost, basically what we saw in our Excel sheet, then it's advantageous to consider an in-house solution, because in the longer run, that will save you the cost. Now, there's one more important factor: cost reduction scope. What we have seen so far is that the in-house numbers that we presented are for the baseline model. So from there, we can really optimize our model. We can optimize our infrastructure, and we can ensure that we can improve our latency and throughput numbers. So by doing a lot of optimizations, performance improvements, we can further bring down the in-house cost of running the service. But on cloud, since it's a flat rate that you have to pay, there's no such cost reduction scope unless you are a big enterprise and you bring a lot of businesses to them. The cost reduction scope in cloud is lesser, but in when it is in-house, you can optimize on a lot of areas, and you can make your solution more performant, and that's how you can reduce the cost. So if cost reduction scope is your factor, then it's better to stick with the in-house solution. If you want to involve a custom model, which means you want to do a model on your, you want to train a model in a custom data set. So even the cloud providers provide you the way to bring your custom model or to train the model on your custom data set, but then they charge more. In fact, they charge 4 times of the current rates. So the normal text translation is $20 per million characters, but with a custom model, it comes to be $80 per million characters. And when it is in-house, after doing multiple rounds of retraining, again, there would be some retraining costs involved, but in the longer run, overall, you'll see that the in-house solution would be cheaper, even with a custom model, custom retrained model, and the cloud would be much costlier. So, yeah. So, and the next factor is the data security and privacy. If you feel that your business use case requires more security and privacy, then it's better to stick with the in-house solution. And yeah. So like these are the factors that that apart from many others, I'm sure there will be many more factors which can affect the choice of cloud versus in-house debate. But if these are your factors, then mostly if you stick with cloud for latency, quality, you're better off. But for in-house, if you want to develop, maybe you can save more on cost, on model training, and you'll have a better and more secure and privacy. You can ensure all of that. So, so that's what we had to share today. The insights that, and actually these insights are coming from our own journey of deciding versus whether we should build a solution in-house, and some of that we have shared with you today. That's all we wanted to present. So actually there would be there's a part 2 and the extension of the current discussion, that how can we further reduce the in-house cost by optimizing the model by optimizing the infrastructure, and that would be the part 2 of this discussion, and that we can take it in the next session. Thank you. That's all we had to share.
Yeah, thank you, Saurav. So the goal of this talk was to give a very methodical approach that one has to take when you want to decide between picking and designing and building something in-house versus going with a cloud provider, be it multiple use cases, right? There's just one use case here, which is Google Translate versus in-house. But having such a framework is very important when you're doing this build versus buy decision. One on the cost aspect, and like Saurav showcased, it's not just cost always which decides if you want to build or buy, right? Like a lot of organizations do have regulations where they're not able to send out their data to cloud, right? So with that data security and privacy in picture, you would want to maybe build it in-house only. So there are various constraints, and you'll have to look at what your organization's parameters are, what are their priorities, and also take this framework and adapt it to your use case, add, remove parameters, change the values, and see. But the goal was just to bring our learnings in a more process oriented and give you that framework that you can use when you want to make such a decision.
Thank you, Sharmili, Saurav, and Raghutam. Let's see if anybody has any questions. By the way, Sharmili and Saurav will also be there at InstaMojo on the 10th of March when we will be having an in-person event to discuss some of the issues that were raised today. So participants who are on Zoom, you can put your question in the Q&A tab or raise your hand and we'll unmute you to ask questions. All right. So the questions can also be posted on the comment section where the stock is listed, and the video will be uploaded tomorrow for everybody to see. And we can also take the questions async. With that, Raghutam, if you have any concluding thoughts, we can take that and close today's session.
Yeah, thanks, Zainab, for pushing us and following up constantly so that we create this content, polish it, and be able to present it to the larger audience of the community. Like we mentioned, this is just the start. We have multiple ideas on how we can share our learnings, and we will do follow-up sessions on how to optimize model, how to optimize the infrastructure, and a lot more. Maybe we'll also do deep dives on the use cases itself on the machine learning data science front as well. Yep. Thank you so much.
Okay, thank you, Raghutam. And for everybody else, you can follow the work of Raghutam, Sharmili, and Saurabh on hasgeek.com/fifth elephant. Thank you, everyone.
Thank
Thank
you.
you all.
Thank you all.